Bismillahirrahmanirrahim. Sallallahu alaihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alaihi wasallam. Ameen. Alhamdulillah rabbil alameen. Differentiation, lecture 3, part 2. We should be soft. Implicit functions. This is the continuation of the implicit functions. The implicit functions means the differentials of y power n with respect to x. Whenever we differentiate y with respect to x, then we always multiply our answer with dy upon dx. Make sure whenever you differentiate y with respect to x, you should multiply your differential, this differential like this one, by dy upon dx. It's compulsory for the implicit functions. I've mentioned this note here, always multiply the differential of y with dy upon dx, like this. This is multiplied by the differential of dy upon dx. Equation of differentiation, lecture 3, part 1. Example, in fact. This is the example which I left for the students to solve in lecture number 3, part 1. So this is the way to solve this equation. This is uv and this is also uv, and this is the rule, uv rule. So here is the solution. First, copy u according to uv rule, and make sure you remember this, you understand this. This is implicit and this is also implicit. So according to uv rule, we need to copy u. This is u and this is v prime. The differential of sine y is cos y times dy upon dx, because cosine y is implicit. And then write v and differentiate u. This is also uv. So according to uv rule, copy u and differentiate cos x. The differential of cos x is negative sine x. And then copy v and differentiate u. The differential of y with respect to x is dy upon dx. Now we just need to simplify this, and this is the answer. An example from March 19, paper 3-2. This is example number 1. March 19, paper 3-2, question 5. One of the most important question of implicit function. Well, sine y is tan x, this is given, where y varies from minus pi by 2 to pi by 2. We need to show this thing. A lot of trigonometry is required, so you must be good at with trigonometry. So this is implicit, this left side is implicit, this is explicit. So whenever we differentiate implicit, we multiply the differential by dy upon dx. And this is explicit, so its differential is simple. The differential of tan is sec square x. Now we can write sec square x as 1 upon cos square x, say equation number 1. Since we need cos x and cos 2x here, therefore we have to remove this cos y. Unless we remove this cos y from this equation, we won't be able to prove this gradient. So this is the most important thing, that we need to eliminate this cos y from this gradient equation. For that, we need to use equation of curve. By using this equation, we can remove this cos y from equation 1. So this is equation number 1. Since I need cos y, therefore I have to square on both sides, because I want to use this identity. Sine square x is 1 minus cos square x. So in order to use this identity, we have to square on both sides. So by squaring on both sides, we have sine square y tan square x. So sine square y will become 1 minus cos square y according to this identity. And tan square x is, this is the identity of tan square x. It's sec square x minus 1. So by making cos square y subject, we have 2 minus sec square x on the other side. So replace sec square x by cos square x, because we need our answer in the form of cos. Now by taking LCM of right side, we have 2 cos square x minus 1. Now you must remember this formula. Cos 2x, it is 2 cos square x minus 1, because 2 cos square x minus 1 is cos 2x. So I replace this numerator by cos 2x because of double angle formula. Now we have to take square root because we need cos y. So by taking square root on both sides, we have got the value of cos y. This is the value of cos y. And we need to substitute this value into equation 1. And this is the equation number 1, the gradient equation. So this is the equation number 1. By substituting cos y into this equation, we have, this is the value of cos y. So by cancellation on both sides, we will get the answer shown. So a lot of trigonometry was required to prove this question. Last question of this lecture, example number 2, June 19, paper 3-1, question 3. This is a routine question. We need dy upon dx of this equation, the implicit function at 1, 3. And in this equation, this is uv, xy square. So this is a routine question. This is the step number 1. Differentiate this carefully. This is uv. So according to uv rule, write 3 outside the bracket to make the uv rule simple. This is u and this is v prime, and v is basically implicit. So multiply v, the differential of v, the differential of y square by dy upon dx. The differential of y square is 2y, and it should be multiplied by dy upon dx. So this is v and this is u prime. And this is simple, y cube is implicit. It will be minus 3y square times dy upon dx. Well, this is the simplified form, and then we have to put 1, 3 into this simplified form. Hence, the gradient is 10 upon 3. No need to make dy upon dx subject into this equation because it is not required. So whenever it is not required, the expression of gradient, never make dy upon dx subject. Just substitute the value in the simplified form, and that's the answer. This is all. We should be honest. Allah Hafiz.